Okay, question 18. The diagram shows a 3-pin plug. Label the 3 pins. Can you tell me? Earth. Then he left wali neutral. He and he live. हाँ socket में उल्टा होता है. हाँ socket में उल्टा होता है. Why are the pins splitted? Okay. No, why is the top pin thicker and longer than the other two? Yes, yes. So that earth pin goes first and establishes the connection first to avoid shock. And thicker, why thicker? Because mistakenly least resistance also, and mistakenly it is not put into the other hole.
Sir,
Okay. Yes.
sir, ते लाईव्ह आणि न्यूट्रल उलटा असायला पाहिजे.
नाही लाईव्ह आणि
राईटला लाईव्ह आहे आणि लेफ्ट न्यूट्रल.
नाही लेफ्टला लाईव्ह आहे, राईटला न्यूट्रल आहे. LN बरोबर आहे, लेफ्टला लाईव्ह आहे. लेफ्टला लाईव्ह आहे आणि हे न्यूट्रल. असंच केलं होतं ना अर्थ का नाही? उलट केलं होतं. ओके ओके ओके. येस येस येस. सो लाईव्ह न्यूट्रल अर्थ आणि इकडे बरोबर काय होईल हे मॅच करायला आहे. हे नॉर न्यूट्रल लाईव्ह अँड अर्थ. करेक्ट. Why are the pins splitted at the ends? Split at the ends. Why? Yes, it gives a spring action, and when it is put into the socket, it fits tightly. Very nice. Okay. Draw diagram of a 3-pin socket. It's here. This is the socket. This is the plug. All right. Identify. To which part of the appliance is the terminal 1 connected? Which part of the appliance? Metal casing. Metal casing. Earth है ना? 1 is earth ना? Where it is connected? Metal casing of the appliance. Metal casing of the appliance. Okay, to which wire joined to 2 or 3 is the fuse connected? 3. To which wire joined to 2 or 3 the fuse is connected? Fuse कुठे connect होतो? Live मध्ये. Live is 3. That's live लिहा आणि वाटलं तर 3 लिहा आणि ब्रॅकेट मध्ये live लिहा. नुसतं live लिहू नका because they want the number. Question मध्ये त्यांनी number विचारलेला आहे. All right. Anyways, next one. What do you mean by the term local earthing? I hope everybody got the clear idea about it. One more thing. This table, old convention and new convention. Color code for the insulation. Now they haven't mentioned whether it is old or new. So it's better to write new. Always new convention is preferred. Dark brown, brown. Live brown. Neutral blue and earth green or yellow. Green or yellow also. Okay, name light blue. Okay, name the color code for the wire which is connected to metallic body earth. Metallic body is earth. Which color? Green or yellow? And switch for the appliance? Live. Switch live. Brown. Live means brown. Okay. A power circuit uses a cable having 3 different wires. Name the 3 wires of the cable. Live, neutral, earth. Between which of the 2 wires should the heating element of an electric geyser be connected? 2 wires, right? So heating element live and neutral. Correct. To which wire should the earthing, metal casing म्हटलं की earthing. To which wire should the switch and fuse be connected? Live. Very nice. Simple. Okay. Next. Give 2 characteristics of high tension wires.
They have many smaller wires twisted together.
Low resistance and high surface area. एवढंच लिहायचं. High surface area. That's all. Which of the cables, one rated 5 ampere and the other rated 15 ampere, will be of thicker wire? 15. Why? To carry more current. Okay, next diagram is interesting. Name the switches to be closed so as to light all the 3 lamps. Which switches have to be closed?
Two and three. कारण की ते series
Only 2 and 3.
Sir, ते second वाला batteryचा.
Yeah, if you close one or not doesn't matter. Yeah, doesn't matter, right? Because if you close 2 and 3, the circuit is complete here. There is a battery. These are in series, so doesn't matter, right? Okay, so 2 and 3 लिहायचे फक्त. How are then lamps connected in series or parallel? Series. Very nice. Okay. 34. Below shows 2 bulbs with switches and fuse connected to the mains through a 3-pin socket by means of a 3 wires. हो का? करूया ना आपण, करूया. Okay, so label each component: bulb, switch, fuse and socket. करा label. So this is bulb.
Neutral.
Switch.
This is switch. What is this? Fuse. Very good. Fuse. And what is this? Socket.
सिम्बॉल दिलेला याच्यामध्ये ते मेन्स होतं.
Record होतोय. थांब जरा. गडबड करू नकोस. 1, 2, 3. You have to name and state the color also. What is 1?
Neutral.
Yes, 1 is neutral. Why? Sorry. Second is earth. Very good, earth. And third is, of course, it is connected. Fuse is connected, so it is live. 3 is live. Tell me the color coding now. Neutral. Neutral काय? Light blue. Green or yellow. And live is brown. Brown. That's all. एवढंच आहे, बाकी काहीच नाही. ठीक आहे? All right. I think there is one question extra in your textbook. Will you able to do it?
Dual control switch.
अच्छा, cancel dual control switch. Okay. How are the 2 bulbs joined in series or in parallel? They are in parallel because current splits here, right? So they are in parallel. All right, great. Done, everyone. Shall we proceed?
Yes, sir.
Okay. Multiple choice. The rating of a fuse connected in the lighting circuit is 5 ampere. Lighting म्हणजे not lightning circuit, not lightning. There is no circuit for lightning. This is lighting circuit, means where the bulbs are connected, and bulbs don't require more than an ampere. 1 ampere is also very high for a bulb nowadays. So 5 ampere is more than enough. A switch must be connected in the live wire, switch and fuse both. All right, so in this way we have completed this chapter. This is one of the simplest chapters in electricity, so to speak, and mostly theoretical. Okay, there is nothing much in terms of remembering formulae and doing numericals, right? So yes, let's start with, can you hear me? Hello?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Oh, wait a minute. Okay, hello, can you hear me now? Yes.
Yes, sir.
Yes, sir.
Nice. Okay. Electromagnetism. I know you have studied electromagnetism from maybe 5th or 6th standard. Electromagnet, taking a battery and a nail and taking a wire and make it winding around the nail, and yes, solenoid kind of thing, and making an electromagnet. And you must have seen that a few pins, stapler pins, get stuck to the nail when you pass the current through it. So electromagnetism is a phenomenon in which magnetism is generated in current carrying conductor. So any conductor, any wire, any conductor, whatever may be its shape, it could be cylindrical, circular, hexagonal, whatever, doesn't matter at all, or ring type. Then if you pass current through it, it is bound to produce magnetism, right? So fundamentally speaking, if electron flows, बघा मी काय बोलतो, if electron flows or moves through the conductor, or even through the vacuum, or even through any other medium, it produces magnetism. This is what is observed, and the first person to observe this phenomenon, electromagnetic or electromagnetism or electromagnetic induction, before that was Hans Christian Ørsted. Okay, he was a scientist, and he was doing an experiment in his laboratory. He was a professor basically in the university, and he was conducting an experiment in the laboratory, and accidentally those in olden days, those used to, most of the people used to have a compass with them. You must have seen in old movies, British movies. Most of them used to have a compass watch. Yes, आणि असं असं ते ओपन करायचे आणि कंपास असायचा, and his compass was lying beneath a conductor, and he was doing regular experiments for preparing for his next lecture, and his compass was lying beneath it, and somehow, I mean, the current was flowing through the conductor, and somehow he noticed that when he stopped or disconnect the current, the needle moved, and then he again started the current, the needle moved in another direction, and that is how he noticed this phenomenon, or this electromagnetic effect. And this is by accident, and you must have seen or learned through through the previous standard that most of the discoveries are accidental discoveries. So ही जी डिस्कवरी होती ही आज मी आता शोध लावणार आहे, मी आता आज शोधच लावून टाकतो, असं झालेलं नाहीये. अनइंटेन्शनल होतं, पण त्यांना हे कळलं, and then he started doing more experiments on this, and then he came with basically the principle की कसं होतं हे वगैरे, then he explained everything. So let's see what electromagnetic or electromagnetism is. Okay, so please pay attention on these 5 diagrams. These are one of the important things you will learn in this chapter. By the way, in this chapter you are going to deal with directions. Okay, directions, you are going to use your right hand, Fleming's right hand rule, Fleming's left hand rule. You are going to use right hand thumb rule. Okay, so many things are there, and which are very, very interesting. And so to understand those, you need to understand these 5 diagrams initially. So look at the first diagram here. So what do you see? You see a normal circuit, correct, which has a rheostat to control the amount of current. You see a battery which gives which is a source of energy. You see the key to open or close the circuit. You see a compass. Now remember, the compass here, and here it is shown dotted, whereas the compass here and here is shown solid. The reason is that in engineering, okay, in engineering drawing, you can ask any engineer, okay, they will tell you that if you have a object in front of, like let's say we have some object here, and let's say we have another object behind it, and if you are looking like this, then while drawing while representing the drawing of it, you represent this as square solid lines, but the object behind is shown dotted like this. This is the convention. आणि मुलांना काय वाटतं, हे चुकलंय, हे डॉटेड दाखवलं, हा हे खाली आहे, हे चुकलेलं नाहीये. आता डॉटेड काय सांगतो? See, the wire is on top. Remember, the wire in first 3 diagrams is on top, and the compass is is below the wire, or behind the wire, you can say below. So when you look from the top, you will see the wire solid, and the compass dotted. This is the convention. Is this clear? हे 100% कळतंय का? This is not a printing mistake.
Yes, sir.
दिस इज नॉट अ प्रिंटिंग मिस्टेक. हे इंजिनिअरिंग ड्रॉइंगचा कन्सेप्ट आहे आणि कधी ड्रॉइंग काढताना असंच काढतात. कन्सेप्ट लक्षात ठेवा. सांगतो ना, तेच तर आहे गंमत. आता बघा, सो इन द फर्स्ट ड्रॉइंग बेसिकली नो करंट इज फ्लोइंग बिकॉज द की इज ओपन, राइट? So we have taken the compass below the wire AB. You have to concentrate only on AB, okay? The part AB of the drawing of the connection, and we have taken this as the direction, okay? So we are facing, basically we are looking like, you know, like this, correct? आपण असं बघतोय from the top, but the needle is facing north, regular, because it has to face north south, right? It is going to face north south. So basically AB is along north south direction. समजताय? हे पहिली concept समजलंय तुम्हाला? So AB is along north south direction. Now second diagram, key is closed, compass needle kept below the wire. आता if you observe clearly, look at the polarity of the battery. Where will the current flow from? It will flow from positive to negative. So the current will flow from A to B. Now current is flowing from south to north. Remember, current कसा flow होतोय? South to north flow होतोय. And the needle gets deflected towards west. बघा इकडे नॉर्थ कुठं गेलीये? वेस्टला गेलीये. मग हे कसं लक्षात ठेवायचं सांगतो तुम्हाला. स्नो लक्षात ठेवायचं. कसं स्नो ते सांगतो तुम्हाला. साऊथ टू नॉर्थ, व्हॉट इज साऊथ टू नॉर्थ? करंट. बघा, साऊथ टू नॉर्थ करंट ओव्हर, व्हॉट इज ओव्हर? वायर इज ओव्हर, ओव्हर वेस्ट, ओव्हर वेस्ट. साऊथ टू नॉर्थ ओव्हर वेस्ट. स्नो लक्षात ठेवा. साऊथ टू नॉर्थ ओव्हर वेस्ट. So what is south to north? If current is flowing south to north, if current is flowing south to north, and if you keep the wire over the compass needle will point to the west. Is this clear? Snow म्हणतात. समजलंय नक्की? पुढचं नोज आहे. त्याच्या पुढचं नोज, मग नोज आणि परत स्नो आहे. करेक्ट. येस. Now next will be what do we do here? We change the polarity. We change the polarity, keeping the compass below the wire. We only change the polarity of the battery. Now the current will flow from B to A. If current flows from B to A, that means current is flowing from south to north. North to south. So north to south. आणि NS NOAC असतं ऍक्च्युली ते, पण NOAC असतं, पण ठीक आहे, नोज म्हणतात, पण हे परफेक्टली मॅच होत नाही ते. एनिवेज, सो नॉर्थ ओव्हर साऊथ ईस्ट असं आहे, पण दॅट्स ओके. इफ यू रिमेंबर स्नो, यू डोंट हॅव टू रिमेंबर एनिथिंग एल्स. सी व्हॉट वी हॅव चेंज? वी हॅव चेंज polarity. You can do two things. Either you can change the polarity or you can change the position of the wire with relative to the compass. If you change both, you are going to get the original thing. बरोबर ना? साधी गोष्ट आहे. Okay, so here when current flows from north to south and the wire is above the compass will move towards east. तर ह्याला nose लक्षात ठेवा तुम्ही. Okay, next. Here again changing the polarity to the original one, but now you have brought the compass above the wire. Now wire is below. So wire is not shown dotted. If you show dotted, that's okay. But ha compass solid दाखवलेला आहे. Solid lines ने compass दाखवलेला आहे. So here we see that if current flows from south to north, the needle turns to what? East. So again it is what? Nose. And lastly, नेस येतं ते, म्हणूनच ते मॅच होत नाही. आणि लास्टली इफ यू चेंज द पोलॅरिटी अगेन keeping the wire below, compass above, you will see the original thing happening, which is snow again. Is this clear? 100% समजतंय सगळ्यांना? All right. So this is what he observed after many repeated observations and experiments, and this is nothing but काय म्हणू इलेक्ट्रोमॅग्नेटिक इफेक्ट. ह्याला इलेक्ट्रोमॅग्नेटिक इफेक्ट. हो 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 होतं ना, होतं. येस, होतं. But okay, so what is the explanation? On passing current in the wire, a magnetic field is produced around it, and the magnetic needle of compass experiences a torque in this magnetic field. So it deflects to align itself in the direction of magnetic field at that point. On increasing the current in the wire, the deflection of the compass needle increases, which implies that the strength of magnetic field around the wire increases. Remember, more the current, more will be the strength of the magnetic field. Distance पण आहे, ते करूया ना आपण. On reversing the direction of current in the wire, the direction of deflection of the magnetic needle of compass reverses because the direction of magnetic field reverses. All right. Inference. हे inference तुम्ही फक्त लिहून घ्यायचं आहे. A current or moving charge. Okay, one more minute. Just a minute here. Look here. If current flows from south to north, from which direction the electrons are flowing? Yes, the electrons are flowing from north to south. Samajhte? Yeah, so basically we don't consider motion of electrons, we consider the direction of current, conventional current. But if electron is also moving, it is capable of producing magnetic field. Samajhte? ठीक है. Anyways, please write down this inference. This is called the magnetic effect of current. The strength of magnetic field depends on the magnitude of current, and its direction depends on the direction of current. Please note this thing. Magnetic field and field lines due to current in a straight wire or straight current carrying conductor. So this is a very simple experiment. I'm sure you must have seen this in maybe 7th standard or maybe in 9th standard, right? So here we have a source of energy. This is positive side, this is negative. Current flows from here. This is a straight current carrying conductor which is being passed through a hole made in a cardboard. Why cardboard? Because cardboard is a non-conducting material, and basically we sprinkle fine iron filings on this, and you will notice that we get concentric circles around the wire. Yes, this is nothing but locus. Why concentric circles? These show the magnetic field lines. हे जे circles आहेत ना, these are nothing but magnetic field generated by the current flowing through the straight conductor. And this compass, if you take a compass, magnetic needle, and just rotate or just move it around the this current carrying conductor, you will see that as you move it, its direction changes. So wherever you point it, and if you draw a tangent, if you draw a tangent here, you will point to the north direction. And you might ask why the arrows are only when you look from the top. Okay, बघा सगळ्यांनी विचार करा, टॉप पासून जर तुम्ही बघितलं तर arrows are clockwise. Can you see? बघा arrows वर्ण जर इमॅजिन करा, तुम्ही वर्ण बघताय, you will see the arrows are clockwise. Now take your right hand, everyone, stretch your thumb and curl the other 4 fingers and see whether you get the direction. So the thumb points to the direction of current in the conductor, and the curled fingers give you the direction of the magnetic field. समजलं? Yes. हा right hand thumb rule है. Okay, don't call it at a thumb rule because thumb rule has a different meaning. Call it as a right hand rule or right hand thumb rule. So now let me ask you one question. Suppose I reverse the direction of current. Now the current is going from bottom to top. Yes, and if you look from the top, you will see the direction changes. Yes. Ata, see, when you basically see, when you spray, look at the iron filings, see, circle doesn't have any direction. So when you look at the iron filings, you will not notice any direction. Remember that. How do you note the direction is by placing the compass, not by looking at the concentric circles of iron filings. That will not give you direction. The direction will be given by the magnetic needle or compass. Is this clear? 100% समजले सगळ्यांना, right? Okay, all right. आता हे 3 points आहेत ते बघूया. From the magnetic field line patterns, we note that the magnetic field lines form the concentric circles around the wire. Just underline the keywords with their plane perpendicular to the straight wire. What do you mean by plane? Plane means plane of the cardboard. And this is the conductor. That's why. Right? So plane of circles is nothing but plane of the cardboard. And conductor is perpendicular. So they are mutually perpendicular like this. To the straight wire and with their centers lying on the wire. So concentric circles have same center. With the direction of current in the when the direction of the current in the wire is reversed, the pattern of iron filings does not change, but the direction of deflection of the compass needle gets reversed. The north pole of the compass needle now points in the direction opposite to the previous direction, showing that the direction of magnetic field has reversed. And third one, on increasing the current in the wire, the magnetic field lines become denser. Underline this. Why? What do you mean by denser? They come closer and closer. जवळ जवळ येतात. This indicates that more the amount of current, more the strength of the magnetic field. More the strength means more dense or closer the lines are. Very, very simple, right? Closer the concentric circles are. And the iron filing gets arranged in circles up to a large distance from the wire. So basically, as you move away from the wire, right, the distance goes on increasing. And if large current flows through the wire, obviously it has a larger field, right? Showing that the magnetic field strength has increased and is effective up to a larger distance. Okay, the magnetic field at any point is a combined effect of magnetic field due to current in the wire and magnetic field of the earth. We have seen this in 9th standard. आठवत आहे दोन vectors होते BV आणि BH. BV is vertical component of magnetic field of earth and BH is horizontal component. Oh, एवढं नव्हतं का? 12वीला गेलो. ठीक आहे.
Magnetic effect of conductor is more than magnetic field effect of earth.
कंडक्टर हा ह्याच्यामध्ये तेच झालंय. हो अर्थातच अर्थचं खूप वीक आहे का? नाही सी नाही effectively when you bring the compass nearer closer to the conductor, the field of the conductor is stronger than the field of earth. Really? म्हणूनच तो चेंज करतो ना, नाहीतर तो अर्थच्या नॉर्थलाच दाखवत राहिला असता कायम. हा नाही तर बरोबर बोललो. आता कधी कमी असेल, when you take this away, very far away, then this does not have much influence. Exactly. नाही जास्त नाही. At points nearer the wire, the magnetic field due to conductor in the wire predominates, due to which iron filing arrange themselves in circles. Earth's influence आहे पण कमी आहे. While at the points far away from the wire, the magnetic field due to earth becomes more pronounced as compared to the magnetic field due to current in the wire. As a result, filings tend to arrange themselves in straight lines. The point where the two fields are equal and opposite is called a neutral point. तुम्हाला माहिती आहे, we have shown this by X. At the neutral point, the resultant, not actual, म्हणजे resultant, म्हणजे effective, net. Effective magnetic field is 0 and the compass needle at this point rests in any direction because it is confused. Okay. Rule to find the direction of magnetic field, I told you, this is called right hand thumb rule. लिहून घ्या. Right hand thumb rule आणि bracket मध्ये लिहा rule to find the direction of magnetic field. So if we hold the current carrying conductor in our right hand such that the thumb points in the direction of flow of current, then the fingers encircle the wire in the direction of the magnetic field lines. Note it, remember it. Okay, this is the diagram. You can have any direction. Just take a pen or pencil, hold it like this, stretch the thumb. Thumb points to the direction of flow of current. Then the curled fingers will point to the direction of magnetic field around the conductor. That's all. Itka simple hai, right? All right. So let's say instead of having a straight conductor carrying current, we have a single loop of wire carrying current. What happens? Interesting thing. You can see here that instead of a conductor, straight conductor, we have a loop. So if you have a loop, let's take the current going from X to P. So at P, you can imagine it is a small part of a straight conductor. So the current is coming up like this. Current is coming up. It is coming up above the cardboard. Take the right hand, and take thumb stretching upwards. You'll see that the curled fingers are anti-clockwise if you look from the top. Anti-clockwise. So they will be like this. Okay. Now the current will go like this. The current from Q will go downwards. Khali janar to. Jar to khali gela, then you have to again consider it as the straight part of the conductor, small straight part. Take your right hand and stretch the thumb downwards along the conductor. You will see that the curled fingers go in clockwise direction. Correct. And this is how the formation is. The last thing to note is the magnetic field lines never cross each other. They don't intersect. So the middle line is straight, so to speak. This is a straight line. So it is passing from south to north. We'll talk about this next time. How to determine the direction